Hi and welcome to RAULI app tutorial. We are going to check the functionality and features of the calculator. We hope that you have time to listen to the entire presentation. The content will be useful for anyone working with solar panels, whether you're an installer, salesperson, expert, or looking solar panels for your own house. You'll sure get useful information from the presentation. We are now in the main menu of RAULI app. Let's start by calculating a single project for a pitched roof. Almost all RAULI app usage is precisely this. Example in situations when an installer checks what components they need to bring for an installation, or a salesperson shows a customer what kind of project they are offering. The software is now asking for project details. Let's name the project after the customer, Customer A. The address is essential because it provides us with the coordinates to retrieve wind and snow loads. In this example, we are installing in Trondheim, Norway to get sufficient snow loads to clarify how the calculator works. The information about the solar panels is important. The thickness of the frame determines what kind of middle and end clamps the software offers. The physical dimensions are even more important. A decade ago, solar panels were clearly smaller, not only in terms of power, but also in terms of size. The size of the solar panels was then about 1.6 square meters. Nowadays there are very big solar panels on the market that are nearly twice of the physical size. It means that also the snow load will be double. In this example, we will use a solar panel that is slightly less than 2 square meters, and has a capacity of 410 watts. This is very close to the most common solar panel currently being installed on pitched roofs. We are planning a solar panel system for a customer A, which will include installing 3 separate systems. One will be installed on the garage roof, and the 2 others on the main building roofs. One for the western roof, and one for the eastern roof. Let's start with the garage roof. Here you can see the icons how you can add or remove panels. You can also change to the horizontal installation, or vertical installation. The icons are super easy to use. Let's install solar panels in 2 rows of 8 panels each. You can add or remove panels as needed. Here you can see the dimensions of the system, which is an excellent feature for a salesperson measuring the customer's roof, to determine the size of system that can be offered. This is also useful for the installer, who is positioning the system on the roof. The calculator will calculate also the middle clamp, so the empty space between the solar panels is included in dimensions. Also the end clamps are included. It means that measurements are correct. If there are any obstacles, such as a chimney, or air conditioning units, you can remove individual solar panels from the layout. RAULI app will correctly calculate the required number of brackets and components after any changes. Let's choose a tile as the roofing material. The choice of roof bracket is naturally determined by the roof material. As different roofing materials have their own attachment methods, the calculation provides different bracket spacing for different materials. The angle affects how much snow accumulates on top of the solar panel and how much stress the brackets are subjected to. The steeper the roof, the faster the snow will slide on the roof. On a shallow roof, the snow will remain in place, resulting in a smaller force pushing the panel downwards toward the ground along the plane of the roof. We have thoroughly tested all RAULI products to ensure their durability. The calculator uses these results to provide accurate figures. In January 2022 the RAULI products got the EU certification, which required use to conduct these tests. We are now installing 16 solar panels to Trondheim in Norway. Let's calculate the bracket spacing. The RAULI app indicates a snow load of 3.5 kN for square meters for the target. It means that one panel can withstand up to 700 kilograms of snow. For a larger panel, the snow mass would be over 900 kilograms. The calculator recommends that RAULI Nordic brackets to be installed on the roof with a spacing of 103 centimeters. Here is a list of components required for the installation. At this point you will see how the calculator works and what factors are taken into account. We can manually adjust the bracket spacing as desired, and the required components will change accordingly. If we increase the spacing beyond what is feasible, based on wind and snow loads, the calculator will give warning, in red color. If we adjust the roof angle to a steeper angle, snow will slide off the panel more quickly, and the bracket spacing will increase to 120 centimeters. Conversely, if we adjust the angle to a shallower slope, where the force pushing the snow load on the panels towards the roof is lower, the bracket spacing will also increase to 120 centimeters. If we switch to the strong type of bracket, the bracket spacing will increase to 120 centimeters. On the other hand, if we use the BTT bracket, which is used on clay tile roofs, in Central Europe, the bracket spacing will decrease to 71 centimeters. For metal roofs, our all-in-one bracket has a spacing of 120 centimeters as well. There may also be a situation where we want to overdesign the mounting system. Trondheim snow load is 3.5 kN per square meter, but we want to design the mounting system for a snow load of 4.5 kN per square meter. Bracket spacing will decrease to 82 cm. With strong and all-in-one brackets, we would have mounting distance of 100 cm. Next, we will change the shape of the field and remove one row. At this point, we have to calculate bracket spacing again. The distance between the brackets decreases by 20 cm, to the 84 cm, due to the weight of the snow on and above the panels pushing the field in the direction of the roof. If there is only one row of panels, the force of the snow is resisted by a significantly smaller number of brackets, than with two rows. For this reason, we have to put more brackets with a single row installation, than with a two-row installation. If we have only one row of solar panels, and we want to overdesign the mounting system to a snow load of 4.5 kN per square meters, which means a mass of 900 kg on top of one solar panel, the mounting distance decreases to 66 cm. From the component calculator, we can see that this requires 30 brackets. If we do not want to install the brackets so closely, we can add a third row of rails, to distribute the snow mass more evenly. This also improves the durability of the solar panel. The mounting distance increases to 99 cm, but the number of brackets remains the same. Of course, more rails are needed, but the number of brackets does not change. Now it's time to add more panel groups. We went through the calculator operations very deeply, and it took a lot of time to calculate the components for the garage roof. Now we will show an example of how long it typically takes for an installer to check the components needed for the day's installation, or for salesperson to present the system for customer. The second panel group is for main building, for the eastern roof. Let's add here 10 panels in 2 rows. Roofing material is standing seam and roof slope is 45 degrees. Bracket spacing is 120 centimeters, and the snow load is of course the same as the last time, because the location is same. Now we add the third panel group. It is also in the main building, but this time the western roof. In here we are going to add 12 panels, there are more space. 2 rows, but in here there is chimney over here, so we must remove a couple solar panels. Roofing material is also standing seam and roof slope is 45 degrees. Now we have all the needed results. As you can see, the calculator is really fast and easy to use. The most important feature of system is the ability to print calculations as a clear document. You can find the PDF icon here, which allows you to print the Picklist. The document shows the details of the project, including the size of the system, dimensions, and all components. The first page displays the garage roof. In the second and the third page, you can see the east and the west roof, also the dimensions, the layout, and all the important information. And the final page shows everything calculated together. The RAULI app also works excellently on mobile phones, allowing the installer to have this PDF in their own device, to make packing the car easier. The salesperson can attach this document directly to the customer, as an attachment to the offer. Now all the systems of customer A have been calculated. We can find here the system for the garage where we use 3 rails, and we over-designed the mounting system for 4.5 kN per square meter. We can find here east roof of main building with 20 panels. And we can find here western roof with 22 panels. Next step is to save these projects in the project basket for later processing. Let's now discuss how to design the RAULI wall installation. We name the project company A Warehouse and the location Berlin, Germany. We will be using the same solar panel module that we used before. Let's name the panel group as a south wall. In this case, the customer has requested solar panels to be installed on the wall, and they have available wall space of 50 meters in width, and 12 meters in height. We need to calculate how many solar panels we can offer them. In here we can see dimensions of the system. We start adding the panels for the system, and we remember that there was installation space of 50 meters. Okay, 43 solar panels go a little bit over, so we take one step back. In height there was space for 12 meters. Let's see how many rows we can add there. 7th row goes a little bit over, so we take one step back. Total amount of panels is 252 solar panels, and it means that size of system is little bit over 103 kilowatts. Here we can see the layout of the system and list of the components that are needed in installation. We can also check the Picklist from PDF icon. Picklist shows us the layout, the panel that we are using, and also every component that is needed in installation. The salesperson can attach this document directly to the customer as an attachment to the offer. At the end we will add this also in the project basket for later processing. Let's talk about the wholesale order. This means situation when you want to order enough RAULI components directly to your own warehouse to last for a long time. Here we see the different roof types and add components for 200 panels icon. By clicking here, the calculator will determine the required number of rails, brackets, end and middle clamps, and all necessary components to install 200 panels for the selected roofing material. Now we will order enough components to install 400 panels with RAULI Nordic brackets, 200 panels with strong bracket, 200 panels for tile-shaped metal roof, and 400 panels for standing seam roof. Now we have all components that are needed for install 1,200 solar panels for these different roof types. When we check the list of components, we can see amount of each component here. We can remove, or add, more components if needed. If there are some extra components you want to put at the same order, you can add them here. At the end, we will add this wholesale order to the project basket for later processing. Finally, we move to the project basket. You can find project basket icon in top right of the screen. The project basket contains all saved projects. There are all 3 systems for customer A, the wall system for company A, and our own wholesale order. We select the projects for which we want to request an offer for components. Check the contact information, and in some cases, the delivery address may be directly to the project site. You can freely add comments to additional information section. Finally, we send the quote request to RAULI people, and shortly someone from RAULI team will get in touch to discuss how to proceed. Thank you for watching the presentation. We hope you found it useful, and we are happy if you would share the RAULI calculator with everyone whose work it will make easier.